physics breakthrough, how solar flares emit enough energy to power our Earth for 20,000 years. Solar flares release a mere minutes enough energy to power the whole world for 20,000 years. Now scientists with NASA determined how this is possible, solving a puzzle that has confounded experts for 60 years. Solar flares, the largest known explosion in the solar system, are triggered by a process called magnetic reconnection that occurs in the plasma. Plasma is a form of superheated gas so energized its atoms break apart, forming a soup of positively charged ions and negatively charged electrons that's exquisitely sensitive to magnetic fields. And reconnection occurs when the geometry of the magnetic field plasma in the plasma is rearranged as a result of field lines getting too close together. To assume a new configuration, field lines break and reconnect, and in doing so release some of the strong energy of the field as heat and kinetic energy, sending particles streaming out from the sun along the field lines. While rare on Earth, plasma is common out in the universe, and magnetic reconnection is known to occur in assorted locations from around black holes or near Earth space and on the surface of the sun. The type of reconnections that sets off solar flares involves collisionless plasmas, in which, as the name suggests, the particles are so spread out they do not collide. The process is also particularly rapid and is thus known as fast reconnection. As astrophysicist Dr. Barbara Giles of NASA's Goddard Space Flight Center in Maryland explains, we have known for a while that fast reconnection happens at a certain rate that seems to be pretty constant. But what really drives that rate has been a mystery until now, she said. In their study, physicist Professor Yi-Hsin Liu of New Hampshire's Dartmouth College and his colleagues at NASA Magnetospheric Multiscale Mission present a theory to explain this consistent reconnection rate, one that relies on a common magnetic phenomenon. This phenomenon, he says, the Hall effect, involves the interaction between magnetic fields and electric currents and describes how charge carriers in a conductor like plasma can be influenced by the presence of a magnetic field. The Hall effect is utilized in such household devices as the sensors that time anti-clock braking systems in vehicles, those that detect when the flip cover of a phone is closed, and even those that allow 3D printers to function. And according to the team, during fast magnetic reconnection, the charged ions and electrons in plasma stop moving as a group and start moving individually. In their study, physics professor Yi-Hsin Liu of New Hampshire's Dartmouth College and his colleagues at NASA Magnetospheric Multiscale Mission presented the theory to explain this consistent reconnection rate, one that relies on a common magnetic phenomenon. And the phenomenon of the Hall effect involves the interaction between magnetic fields and electric currents, describing how charge carriers in a conductor like plasma can be influenced by the presence of the magnetic field. Now, this gives rise to the Hall effect, creating the unstable energy vacuum at the point of reconnection, which then implodes thanks to the pressure of magnetic fields and releases immense amount of energy at the predictable rate. Professor Liu, deputy lead of the MMS theory and modeling team, said, "We finally understand what makes this type of magnetic reconnection so fast." He says, "We now have a theory to explain it fully." NASA's Magnetospheric Multiscale Mission will be testing this theory in the coming years using their 4 specialty designed satellites which orbit the Earth in a tetrahedral formation, studying reconnection as it happens at a high resolution that would be possible on our Earth. It gives rise to the Hall effect, creating an unstable energy vacuum at the point of reconnection, which then implodes thanks to the pressure of the magnetic fields and releases immense amount of energy at a predictable rate, they said. Professor Liu, deputy lead of the theory modeling team, said, "We finally understand what makes this type of magnetic reconnection fast, and we have a theory to explain it fully." NASA's magnetospheric multi-scale mission will be testing the theory in coming years using their 4 special designed satellites orbiting the Earth. Dr. Giles said, ultimately, if we can understand how magnetic reconnection operates, we can better predict events that can impact us on Earth, like geomagnetic storms and solar flares. The energy from solar flares can disrupt transmissions in the upper atmosphere, thereby throwing off, for example, the signal sent from GPS satellites. The astrophysicist said, if we can understand how reconnection is initiated, will also help energy research because researchers could better control magnetic fields in fusion devices. The full findings of the study were published in the journal Communication Physics. And this is on Express UK by Ian Randall. Please leave your comments and thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.